Welcome back to the ClueShare channel. We've recently discussed the concept that the Internet of Things, or IoT, is revolutionizing the healthcare industry, and we reviewed a few current and projected examples of applications. In this video, we will focus more on gaining an understanding of the general architecture of IoT, and also exploring the architecture of IoT specifically in relation to healthcare-specific implementations. At its core, the Internet of Things is a concept that describes the network of physical devices, vehicles, appliances, wearables, and other items embedded with sensors, software, and connectivity, which enables these things to connect, collect, and exchange data. It's like giving everyday objects a voice and a means to communicate, creating a world where everything is interconnected. Since someone watching this may not be familiar with what exactly IoT is, I'll share 3 ways in which it can be explained. My CompTIA plus Guide to Technical Support textbook defined IoT as any device that can connect on the internet for a specific purpose, such as a smart thermostat or door lock. According to Oracle Canada, the Internet of Things, IoT, describes the network of physical objects, things, that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. And lastly, Wikipedia explains that the Internet of Things describes devices with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the internet or other communications networks. The Internet of Things encompasses electronics, communication, and computer science engineering. I'll share the necessary links in the description box below. So what does this mean for healthcare? Imagine a scenario where your doctor receives real-time data about your health condition directly from your body. An existing example of this is a continuous glucose monitoring device, or CGM device, that not only assists the wearer to monitor and check their glucose levels at any time at their convenience, but that also produces warnings and reminders about glucose levels, eating times, and medication. Its related apps create real-time reports and send information to the user's assigned medical professional. In one of my previous technical support roles, I assisted users with this very technology. This is a world where medical devices can talk to each other, making patient care seamless and more efficient. This is the same world where hospitals can monitor and manage their equipment in real time. As previously discussed, the potential implications of IoT in healthcare is immense. Saving lives by providing doctors with real-time information, enabling both patients or users and medical professionals to make swift, informed decisions. Reduce healthcare costs by automating routine tasks and improving resource utilization. And most importantly, it could significantly improve patient care by personalizing treatment plans and improving the patient experience. Another example of IoT assisting patients is a heart patient with a wearable device that continuously monitors their heart rate and sends alerts to their healthcare provider if an anomaly is detected. While these are just a few examples of how IoT is transforming healthcare, it's not just about the cool gadgets and the high-tech wizardry. It's about creating a healthcare system that is patient-centric, data-driven, a reliable and timely support for healthcare providers and other medical professionals in the provision of care, and ultimately a more effective resource. So how does this sophisticated system work? Let's delve into the architecture of IoT and the architecture of IoT in healthcare. The architecture of the Internet of Things, IoT, refers to the structure or framework that enables the seamless connection, communication, and data exchange among various IoT devices and systems. IoT architecture typically involves several layers, each serving a specific purpose in the overall functionality of the IoT ecosystem. Here's a simplified explanation of the key components. 1. The perception layer. This is the bottom layer where physical devices and sensors are located. 2. The network layer. The network layer is responsible for transmitting the data collected by sensors to the cloud or other processing units, and can include communication protocols like Wi-Fi, Bluetooth, Zigbee, or cellular networks. 3. The middleware layer. The middleware layer acts as a bridge between the devices at the edge and the data processing systems in the cloud. It handles tasks like data filtering, aggregation, and protocol translation. This layer ensures that data is efficiently transferred and processed. 4. The cloud layer. Once collected, this is where the data is stored, processed, and analyzed. This is the layer where analytics, machine learning, and data visualization play an important role. 5. The business layer. The business layer involves applications and services that use the processed data to gain meaningful insights or trigger specific actions. And finally, 6. The application layer, referred to as the topmost layer. This is the point at which the IoT interacts directly with end users or other systems using interfaces or dashboards. The architecture of IoT in healthcare involves several key components. These components form the backbone of the IoT system, enabling it to function as a cohesive and interconnected network. While this is a more simplified version, a more detailed review will be posted on our blog on clueshare.org. Firstly, we have sensors and devices. Consider the perception layer. These are the eyes and ears of the IoT system. They're responsible for gathering the essential data that the rest of the system relies on. Whether it's a heart rate monitor tracking a patient's pulse or a smart thermometer measuring the temperature of a vaccine vial, these devices are constantly collecting and transmitting data. Next, we have the connectivity and communication component. Think of the network layer. This is the nervous system of the IoT architecture, transmitting data from the sensors and devices to the data processing unit. This can be achieved through various means, such as Wi-Fi, cellular networks, or even satellite communication. The key here is to ensure a seamless and uninterrupted flow of information. The third component is data processing, like the middleware and cloud layers. This is the brain of the IoT system. It's where all the raw data collected by the sensors and devices is turned into meaningful information. Advanced algorithms and artificial intelligence are often used here to analyze the data and spot patterns or trends that might otherwise go unnoticed. Finally, we have the user interface. In terms of the business and application layer, this is how the processed data is presented to the end user, which could be a doctor, nurse, or even the patient themselves. The user interface needs to be intuitive and user-friendly, allowing the user to easily understand and make use of the data. Each of these components plays a crucial role in the IoT architecture, but it's the way they work together that truly makes the system efficient. The sensors and devices gather data, the connectivity and communication component transmits this data, the data processing unit analyzes it, and the user interface presents the results. These components work together to create an efficient and interconnected healthcare system. The beauty of IoT in healthcare is that it's a living, evolving entity, constantly learning and adapting to provide the best possible care. Let's start with the first component, sensors and devices. In the realm of healthcare, these can be as varied as the medical conditions they monitor. They are the silent heroes, working tirelessly to collect patient data in real time, forming the eyes and ears of the Internet of Things in healthcare. Imagine the option of having your health data securely monitored 24 hours a day, 7 days a week. Imagine a device that records your heart rate, blood pressure, and oxygen levels, all without you lifting a finger. Thanks to the advancements in sensor technology, this is not only a reality, but in modern times, a normalized experience. These sensors, often integrated into wearable devices like smartwatches or fitness bands, are becoming increasingly sophisticated. They can track a wide range of health metrics, including body temperature, sleep patterns, and even stress levels. It's not just about the quantity of data collected, but the quality of it. While no algorithm, system, or device is perfect, and there have been a few recent debates about the accuracy of some sensors and their outputs, for the most part, these sensors are designed to be highly accurate, capturing the most minute and up-to-date changes in a patient's health status. But what happens to this data? It's not just collected for the sake of it. The data serves a crucial role in proactive healthcare management. By continuously monitoring these parameters, healthcare providers can detect anomalies early, often before the patient is even aware of them. This can lead to early intervention, improving the chances of a successful treatment and potentially saving lives. In addition, this real-time data can also be used for research purposes. By analyzing large amounts of health data, researchers can identify trends, predict outbreaks, and develop new treatments. These sensors and devices are therefore not just passive data collectors, but active contributors to the advancement of medical science. But that's only half the story. Once the data is collected, it needs to be transmitted. That's where our second component comes in. The second component is connectivity and communication. In the vast expanse of the Internet of Things in healthcare, the role of connectivity and communication is akin to the nervous system in the human body, transmitting vital information from one point to another. But how does this transmission occur? Let's take a closer look. When a sensor or device captures data, it needs to reach its destination, the data processing systems. This journey is made possible through various methods of connectivity. Each method has its unique characteristics, and the choice often depends on the specific needs and constraints of the healthcare environment. First, we have Wi-Fi. Wi-Fi is a popular choice due to its high-speed data transmission and extensive range. In a hospital setting, for instance, Wi-Fi can connect numerous devices across multiple floors, facilitating real-time monitoring and quick response times. Next, we have Bluetooth. Bluetooth is particularly useful for short-range connections, such as between a wearable health device and a patient's smartphone. It's energy efficient, which is crucial for devices that need to run for extended periods on battery power. Then there's Zigbee and Z-Wave. These are wireless protocols designed for low-power devices that don't require high-speed data transmission. They're often used for home automation, but in healthcare they can be used for patient home monitoring systems. Last but not least, we have cellular connectivity. This comes into play when the device needs to send data over long distances, for example, patient monitoring in remote areas. Cellular connectivity offers wide coverage, although it can be more power-hungry and expensive. In a nutshell, the choice of connectivity method depends on factors such as range, speed, power consumption, and cost. Regardless of the method, however, the goal remains the same: to ensure a seamless and reliable flow of information from sensors to data processing systems. Once the data is transmitted, it needs to be processed. This is done by our third component. The third component is data processing. Let's dive right into it, shall we? Data processing is the beating heart of the IoT architecture. It's where all the magic happens. The raw data collected from various sensors and devices, which we have discussed so far, is processed and analyzed to provide valuable insights. So, how does this work? Well, consider the data processing stage as a gigantic sieve. It sifts through the mountains of raw data, discarding what's irrelevant and keeping what's pertinent. But it's not just about separating the wheat from the chaff. It's also about transforming this useful data into something meaningful. This is where artificial intelligence, or AI, and machine learning come into play. These technologies are like the master chefs of our data kitchen. They take the raw ingredients and whip up a delightful dish of information. AI, with its ability to mimic human intelligence, can analyze data patterns, make predictions, and even make decisions based on the data it's fed. Machine learning, a subset of AI, learns from the data, improving its analysis and prediction capabilities over time. Imagine a patient with a chronic condition monitored using IoT devices. These devices constantly feed data about the patient's vitals to the system. AI algorithms process this data, detecting patterns and trends and alerting healthcare professionals if they spot any anomalies. Similarly, machine learning can predict potential health issues before they become critical. For instance, it might predict a potential spike in a diabetic patient's blood sugar levels based on their eating habits, physical activity, and previous blood sugar readings. This is the power of data processing in IoT healthcare. It's not just about collecting data, it's about making sense of it. It's about turning raw, seemingly unrelated data points into a coherent narrative that can help save lives and improve health outcomes. Finally, the processed data needs to be presented to the user. This is done by our fourth component. The fourth and final component is the user interface. Now, what does this mean, and why is it crucial in the IoT architecture of healthcare? The user interface is essentially the final frontier where the processed data is presented to the end user. It's the bridge between the complex data processing systems and the healthcare professionals or patients who need this information. In healthcare, this interface is often designed to be simple, intuitive, and user-friendly, as it needs to cater to a wide range of users, from tech-savvy doctors to patients who may not be as technologically inclined. It's all about presenting the right information at the right time, in the most digestible format possible. Let's consider an example. Imagine a patient suffering from diabetes. They use an IoT device to monitor their glucose levels. This device collects data, sends it to a central system for processing, and then presents it on a user interface. The patient can see their glucose levels in real time, track changes, and even receive alerts if their levels go beyond a certain threshold. Similarly, healthcare professionals can use this data to monitor their patients' health remotely, track their progress, and make informed decisions about their care. It's a win-win situation, with the patient gaining more control over their health and the healthcare professional gaining a more detailed and accurate picture of their patient's condition. Furthermore, the user interface isn't just about presenting data, it's also a platform for interaction. Users can input data, adjust settings, and even communicate with healthcare professionals. It's a dynamic two-way street that encourages active participation from the user. To sum it up, the user interface in the IoT architecture of healthcare is all about transforming raw, complex data into meaningful, actionable insights. It empowers users, whether they are healthcare professionals or patients, to make informed decisions, improve patient care, and ultimately enhance the quality of life. So now that we understand the architecture of IoT in healthcare, let's summarize the main points. Let's recap what we've learned about the architecture of IoT in healthcare. We've journeyed through the intricate framework that powers this transformative technology, and we've discovered how it's ushering in a new era of patient care and medical advancements. We began our journey with an overview of the general architecture of IoT, then focused specifically on the architecture of IoT in healthcare. We uncovered that this isn't just a single component system, but rather, it's a complex structure comprised of key components that work in harmony. These components include the sensors and devices, the connectivity and communication, the data processing, and the user interface. Each component plays a unique and vital role in the overall functioning of the system. The first component discussed, sensors and devices, are the eyes and ears of the IoT system. They are responsible for gathering a vast array of health data from patients. This includes everything from heart rate and blood pressure to glucose levels and body temperature. These devices are becoming more advanced and less intrusive, allowing for seamless integration into patients' daily lives. Next, we dove into the world of connectivity and communication. This is the bridge that carries the collected data from the sensors to the processing units. It's the veins and arteries of the IoT, ensuring that data flows smoothly and securely from one point to another. We discovered that this could be achieved using various technologies such as Wi-Fi, Bluetooth, and cellular networks. Then, we explored the realm of data processing. This is where the raw health data collected is transformed into meaningful information. It's the brain of the IoT system, analyzing and interpreting the data to provide actionable insights. This step is crucial as it enables healthcare professionals to make informed decisions about patient care. Finally, we ventured into the final component, the user interface. This is the face of the IoT system, where all the processed data is presented in an understandable and accessible way. It can be an app on a smartphone, a dashboard on a computer, or a report on a tablet. It's the platform that allows patients and healthcare professionals to interact with the data and use it to improve health outcomes. All these components together create a harmonious symphony, transforming raw data into valuable insights and ultimately better healthcare. But it's important to remember that the IoT in healthcare is more than just technology. It's about improving patient care, reducing healthcare costs, and creating more efficient and effective healthcare systems. The architecture of IoT in healthcare is a testament to the power of technology and its potential to revolutionize industries. It's a beacon of hope for a future where healthcare is more personalized, more efficient, and more accessible. With a deeper understanding of how IoT can transform healthcare, imagine the endless possibilities for patient care and medical advancements in the future. This video was produced by clueshare.org. Thanks for watching. Be sure to like, comment, share, and subscribe for more videos. You can also check out our full blog post on this topic on clueshare.org. Thanks for joining us and see you soon.